This video, we're going to try to take apart and understand electrolytic cells. So far we've seen voltaic cells. Now we're looking at electrolytic cells. It's important to know that if we were saying electrochemical cells, those can be split into either voltaic cells or electrolytic cells. So the electrolytic cells are non-spontaneous, but voltaic are spontaneous. That the voltaic cell is going to have the strongest oxidizing agent here, strongest reducing agent here in the data table. For the electrolytic cells, the strongest oxidizing agent is below the strongest reducing agent. That these are going to be non-spont, and these are going to be spontaneous. And so we're going to go into the differences and similarities, but electrochemical cells is a term that applies to both voltaic cells and electrolytic cells. And sometimes people, just because they see electro, assume that that word means the exact same thing as electrolytic. Electrochemical is a catch-all term for both voltaic and electrolytic cells. So just please don't be thrown off by that in the future. Electrolytic cells, the process in which electric energy is used to bring about a non-spontaneous chemical reaction is called electrolysis. So spontaneous redox reactions can be used to generate electric current, but in order to make a non-spontaneous reaction occur, you need to supply electric current. So electrolytic cells are electrochemical cells used to cause chemical change through the application of electrical energy. So here's a question that says electrolysis is used to do what? So electrolysis is used to split or to do a non-spontaneous chemical reaction. It converts chemical or electrical energy into chemical potential energy. Here it says, how are voltaic cells and electrolytic similar and different? And I've got a nice little table that sort of shows this. So I'd like you to focus on this. You may need to pause the video here and make this table for yourself. But essentially, many things are very similar between voltaic cells and electrolytic cells. So the cathode and the anode are still going to undergo the same kind of reaction. So cathode is going to be OA, that's the cathode. LEO, RA, is the anode. That's the same for both kinds of reactions. Something that's different, though, is that the cathode is the positive electrode in the voltaic cells, it's negative in the electrolytic. For the anode, it's still going to be LEO, RA, anode for both of them. But again, the positive or negative is switched. So for a voltaic cell, the cathode is positive and the anode is negative. But it's the opposite for an electrolytic cell. Electrolytic cell, the electrode that is negative is the cathode and the positive is the anode. And we'll try to hopefully make that makes more sense later. But another similarity is that the electrons are always going from the anode to the cathode, so they're always going from where they're lost to where they're gained. That the anions travel to the anode and cations go to the cathode, that's the same in both the kinds of cells. One of the differences is, though, that voltaic cells are spontaneous and they have a positive voltage. Electrolytic cells are non-spontaneous and have a negative voltage. And one other difference is that a voltaic cell needs a salt-water bridge. So it needs something like a saltwater bridge or something that's going to separate the two half reactions. Electrolytic cells don't need that because it's a non-spontaneous reaction. It wouldn't happen. It would happen even without the saltwater bridge. So the saltwater bridge in the voltaic cell was to keep these two half reactions separate from each other, because if I had this all happening in one beaker and I had the two electrodes in the same beaker, the electrons would just travel through the electrolyte solution as well as the ions, and the reactions would just happen here and here, and we wouldn't actually get any current. So the saltwater bridge allows for that external circuit for the electrons to travel from one electrode to the other. So that's a difference between the to different kinds of systems as well. Let's go back to your notes here. So, that's